Hello guys, today we are going to cover object-oriented programming principles and benefits of object-oriented programming, followed by applications of object-oriented programming. So this object-oriented programming is a programming paradigm. Paradigm means it's a pattern based on the concepts of objects. So object is nothing but it's a real-time entity. In object-oriented programming, everything we will represent in terms of objects. So this object contains data and code. So data in the form of fields, often we call it as attributes or properties, and the code in the form of methods, that is also known as a procedures. Now, sir, what are the object-oriented programming principles? These are the following six are the principles of the object-oriented programming. That is class, object, data abstraction, encapsulation, inheritance, polymorphism. These are all called as the principles of object-oriented programming. So now we are going to cover one by one. Sir, what is this class? Basically, class is nothing but it's a collection of objects of similar type, right? So this is also called as a template, or you can call it as a blueprint. So by using this class, you can also represent it as a model to represent the objects. Let's say here, if I am taking the flower, flower is a class. It is a model which represents the different objects. Here, if you are taking the objects, rose is a flower, and jasmine is a flower, and sun is a flower, sunflower. So these are all the objects which are existed in the real time. The things which are existed in the real time, they are called as the objects. They are the real world entities. So we can see in these real world objects, we can touch it, right? These objects contains the state, behavior, and identity. So whereas a class that can be called as a template or blueprint or logical entity, right? Here I'm given the example. Here fruit is a class and mango is a object of the class, right? This is how we define the class. Sir, what exactly object? Objects are instance of the class. Sir, what do you mean by instance? Instance is nothing but result, a result of a class that can be called as a object. And this object, it contains, as I said, it contains the different characteristics, like it contains the state, it contains the behavior, and it contains the identity. Sir, can you explain with a simple example? Here I am taking the example, pen is a object. For example, I am taking pen as an object. So its name, I'm taking the name as something, Reynolds is the name of the pen. And I'm taking color as white. So here, this is the Reynolds is the identity. The color white is the its state, and the purpose of it is which is used to write. That is called as a behavior. This is the behavior. This is the state, and this is the identity. Every object, it contains the identity, state, and behavior. So by using these real-time objects, we are going to implement the object-oriented programming uh, in our applications. Now, coming to the next feature, encapsulation. Sir, what is this encapsulation? Wrapping up data and functions into a single unit, that is called as a encapsulation. Here, class is the best example for the encapsulation, right? So here in class, what we are going to do, we will define this as, technically, it's a collection of data members and member functions. So data members are nothing but variables, and member functions are nothing but actions which we are performing, right? So this is the best example for the encapsulation. Now coming to the next feature, that is the abstraction. Abstraction, it represents uh, hiding the essential features without including the background details or explanation of a particular action, right? So that is nothing but abstraction. In simple terminology, hiding the unnecessary details from the user, that is called as a abstraction. So whenever we are going to deal with this abstraction, there I'm going to explain you about this abstraction in detail, right? As of now, just you uh, remember, like it's a representation of or representing the essential features without including the background details. That's it. That is nothing but the abstraction. Now coming to the next one, inheritance. Sir, what is this inheritance means? Let's say here you have a class. It has some ABC features. Sir, I'm writing one more class. The first class, assume it as X. Next class, assume it as Y. Sir, in Y class, whatever the features which are there in the X class, same features I want to take in the Y class. So instead of writing again, rewriting, what we will do, we will reuse the same code which is there in the X class. So the existing class, we are calling it as a super class, or you can call it as a base class, or you can call it as a parent class. So what I want to do, I want to take the features from the existing class or the super class into newly created class that we can call it as a subclass. So acquiring the properties from superclass to subclass, this mechanism is called as inheritance, right? Sir, what is the benefit out of this inheritance? We are reusing the code. We are not rewriting the code. The code reusability is the main advantage with the inheritance. And coming to polymorphism. So, sir, what is this polymorphism? How we are going to implement it? Beta, poly means many, morphism means forms. Basically, if one thing exists in many forms, that is called as polymorphism. But according to our technical definition, so polymorphism means if one method, if it is performing different actions, then that is called as a polymorphism. Sir, how a method is going to perform different actions means that depends upon parameters, the type of parameters and number of parameters which we are passing. Based on that, the method is going to perform the different actions. So that is called as a polymorphism. There we have the runtime polymorphism, compile time polymorphism. These are all the things we will cover in the due course. There we have in detail discussion about this polymorphism. Chalo guys, thank you.